Acids, bases, and salts. Lesson preview. Acids and their properties. Reactions of acids with metals and carbonates. Uses of acids. Bases and their properties. Reactions of bases with acids. Uses of bases. Indicators. Neutralization. Neutralization reactions in everyday life. Salts and their properties. Uses of salts. We consume a variety of substances in our daily life. They all taste different. Some are sweet, some are salty, while others are sour or bitter. We differentiate among these substances on the basis of their taste. Chemical compounds can be broadly categorized into acids, bases, and salts. Most of these substances have a sour taste, while the rest are sweet or salty. Acids. Items such as lemon juice, orange juice, vinegar, curd, amla, and tamarind taste sour. The sour taste of these items is due to the presence of a substance called acid in them. The word acid comes from the Latin word acidus, which means sour. Substances which contain acid are acidic in nature. Different substances contain different acids. Some acids occur naturally in food items and other substances. Such acids are called naturally occurring acids. Given below is a list of naturally occurring acids and the substances in which they are found. Acid. Substances in which it is found. Acetic acid. Vinegar, tomatoes. Tartaric acid. Grapes, tamarind, raw mango. Citric acid. Lemon, citrus fruits. Ascorbic acid. Amla, citrus fruits. Malic acid. Apples. Oxalic acid. Spinach, guava. Lactic acid. Sour milk, curd. Formic acid. Ant sting. Tannic acid. Tea. Naturally occurring acids are also called organic acids. In addition, there are some acids which are obtained from minerals. We call them mineral acids. They include hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. Most mineral acids are strong. They can cause serious burns. Our stomach also produces hydrochloric acid which helps to digest food. Properties of acids. Some physical properties of acids are listed below. Acids have a sour taste. Acids turn blue litmus red. Acids are corrosive in nature. Strong acids can destroy paper, cloth, or wood. Acids also corrode metals such as iron and aluminium. So, acids are not stored in metal containers. Glass containers are used to store acids. Acids are soluble in water. When an acid is dissolved in water, a dilute solution of the acid is formed and heat is given out. Hence, it is dangerous to add water to acid. To dilute an acid, always add acid to water, stirring constantly. Some chemical properties of acids are listed below. Reaction of acids with metals. All acids contain hydrogen atoms. Dilute acids react with some metals to form salt and hydrogen gas. The metals replace the hydrogen of acids to form salts. Similarly, sodium, potassium, calcium, iron, lead, and aluminium replace hydrogen from acids to form salts. Less reactive metals such as copper, silver, and gold cannot replace hydrogen from acids. Mg, magnesium pluva, 2HCl, hydrochloric acid, MgCl2, magnesium chloride plus, H2, hydrogen, Zn, zinc plus, H2SO4, sulfuric acid, ZnSO4, zinc sulfate plus, H2, hydrogen. Reaction of acids with carbonates. Dilute acids react with carbonates. Sodium carbonate Na2CO3 or calcium carbonate CaCO3 to form salts and carbon dioxide CaCO3, calcium carbonate plus 2HCl, hydrochloric acid CaCl2, calcium chloride, plus CO2, carbon dioxide, plus H2O, water, Na2CO3, sodium carbonate, plus H2SO4, sulfuric acid, Na2SO4, sodium sulfate, plus CO2, carbon dioxide, plus H2O, water. Uses of acids. Hydrochloric acid. Its major uses are to dissolve oil-bearing rocks in oil industry, manufacture of chemicals such as glue, in purification of salts, in removing scales, deposits formed inside boilers, in a process called descaling, to make aqua regia. Aqua regia is a solution of hydrochloric acid and nitric acid in the ratio of 3:1. It is used to dissolve metals such as gold and platinum. Sulfuric acid. It is one of the most widely used chemicals in industry. Its main uses are manufacture of fertilizers such as ammonium sulfate and superphosphate, in automobile batteries, manufacture of detergents, manufacture of drugs, plastics, paints, etc., manufacture of copper sulfate, Epsom salts, etc., in textile, paper and leather industries. Nitric acid. Its main uses are manufacture of fertilizers, i.e. ammonium nitrate, manufacture of explosives, i.e. TNT, trinitrotoluene, and nitroglycerin, preparation of aqua regia, in extraction of some metals from their ores, in purification of silver and gold. Bases. In Activity 1, we have seen that some substances like baking soda are bitter in taste. The solution of baking soda is soapy to touch. This is so because baking soda is basic in nature. Substances which are bitter in taste and soapy to touch are called bases. The nature of such substances is said to be basic. A list of commonly found bases and the substances in which they are found is given below. Base. Substances in which it is found: sodium hydroxide, soap; potassium hydroxide, soap; calcium hydroxide, lime water; ammonium hydroxide, window cleaning solution; magnesium hydroxide, milk of Magnus. A base has chemically opposite properties as compared to an acid. So, a base can neutralize the acidity of an acid. Metal oxides, carbonates, bicarbonates, and hydroxides are some examples of bases. Bases that are soluble in water are called alkalis. Bases insoluble in water are not alkalis. Thus, all alkalis are bases, but all bases are not alkalis. Some common alkalis are types of bases. Like acids, bases are also strong and weak. Strong bases such as sodium hydroxide and potassium hydroxide are corrosive and can burn the skin. Bases such as magnesium hydroxide, copper hydroxide, and ammonium hydroxide are weak bases. Properties of bases. Bases are hydroxides of metals. They have a bitter taste. They turn red litmus blue. They have a soapy feel. They react with acids to give salt and water. Some chemical properties of bases are reaction of bases with acids. Bases react with acids to form salts and water. NH4O, ammonium hydroxide, plus HCl, hydrochloric acid, NH4Cl, ammonium chloride, plus H2O, water, FeO3, iron hydroxide, plus 3HNO3, nitric acid, FeNO33, iron nitrate, plus 3H2O, water, 2LO3, aluminium hydroxide, plus 3H2SO4, sulfuric acid, Al2, SO43, Aluminium sulfate plus 6H2O, water. Uses of bases. Calcium hydroxide. It is commonly known as slaked lime. Its main uses are as a substitute for cement in cheap construction, for whitewashing of buildings, manufacture of bleaching powder, for neutralizing acidity in soil caused by excessive fertilizer use, for treatment of wastewater and neutralizing its acidity which may harm aquatic plants and animals. Sodium hydroxide. It is commonly called caustic soda. It is commercially prepared from concentrated salt water, brine. Its main uses are manufacture of soap, manufacture of several industrial chemicals, such as sodium hypochlorite, manufacture of rayon, paper, textile, medicines, etc. Ammonium hydroxide. Its main uses are manufacture of fertilizers, such as ammonium nitrate, manufacture of nylons, plastics, dyes, etc. To removing spots from clothes, etc. Indicators. We cannot taste each and every substance. Moreover, it may be dangerous to touch an unknown substance. Then how do we find out the nature of a substance? To test if a given substance is acidic or basic, there are special kinds of substances called indicators. They change their color when added to an acidic or a basic solution. Examples of naturally occurring indicators are turmeric, litmus, China rose petals, gurahal, red cabbage juice, etc. Naturally occurring indicators. Litmus. Litmus is the most commonly used indicator. It is a natural indicator. It is extracted from a lichen, a plant-like organism. Its color in distilled water is purple, mauve. Its color is red in an acidic medium, and blue in a basic medium. It is available in the form of a solution or in the form of strips of paper called litmus paper. Generally, two types of litmus paper are available: red litmus paper and blue litmus paper. Activity. Take different samples like lemon juice, tap water, detergent solution, vinegar, aerated drink, milk of magnesia, baking soda solution, lime water, salt solution, etc. Put a drop of each solution on separate red and blue litmus paper strips. Record your observations in a table in the same manner as given below. Serial number. Test solution. Effect on red litmus paper. Effect on blue litmus paper. Inference. 1. Lemon juice. No change. Turns red. Acidic. 2. Tap water. No change. No change. Neutral. 3. Detergent solution. Turns blue. No change. Basic. Note: lime water is prepared by dissolving a chuna, lime, in water. Solutions which do not change the color of either red or blue litmus are known as neutral solutions. These solutions are neither acidic nor basic. Turmeric. Turmeric, which we use in the kitchen for cooking, is another natural indicator. Activity. Take some turmeric powder in a bowl. Add a little water to it. Make a paste. Spread a thin layer of the paste on a blotting paper/filter paper, and let it dry completely. Cut thin strips of this yellow filter paper. Put a drop of soap solution on the strip. Observe what happens. You will see that it turns reddish-brown in color. You must have seen that a stain of turmeric on a white cloth turns red when washed with soap. This is because soap solution is basic in nature. Test the solutions given in the table on the strip of turmeric paper, and note down your observations. Turmeric is yellow in neutral and acidic solutions. It turns red in basic solutions. China rose. China rose or hibiscus, gurahal, is a flower whose petals are used as a natural indicator for identifying acids and bases. Take some petals of China rose in a beaker, add warm water to it. Keep the mixture for some time till the solution becomes colored, pink. The colored water acts as an indicator. It is seen from the above activity that acidic solutions turn magenta and basic solutions turn green when the China rose indicator is added. Synthetic indicators. In addition to natural indicators, there are synthetic indicators which are made in the laboratory. The two most common synthetic indicators are phenolphthalein and methyl orange. Indicator. Original color. Color in acid medium. Color in basic medium. Phenolphthalein methyl orange. Colorless orange. Colorless red. Pink yellow. Note: the above activity must be performed under the supervision of your teacher, as the acids and bases used here are corrosive in nature, irritating, and harmful to the skin. Neutralization. The reaction between an acid and a base is called neutralization. When an acid is added to a base, they neutralize each other's effect. During the neutralization process, salt and water are produced with the release of heat. Acid plus base, salt plus water plus heat is evolved. The salt formed may be acidic, basic or neutral in nature. Activity. Take a little dilute hydrochloric acid in a test tube, about 1/4. Add a few drops of phenolphthalein indicator. Shake the test tube gently. What do you observe? Now add a drop of sodium hydroxide solution. Stir the test tube. Is there any change? Continue adding sodium hydroxide solution drop by drop with constant stirring till you can see pink color. Now add a drop of dilute hydrochloric acid. You will see that the solution becomes colorless. You will also notice that the test tube becomes warm. Again add a drop of sodium hydroxide solution. The solution becomes pink again. This shows that the solution is initially colorless as the solution is acidic. On continuously adding sodium hydroxide, the solution becomes basic and gives a pink color. When one more drop of acid is added, the acid and base neutralize each other's effect. When an acidic solution is mixed with a basic solution, both the solutions neutralize the effect of each other. The acidic nature of the acid and the basic nature of the alkali is destroyed. The resulting mixture is neutral, i.e. neither acidic nor basic. HCl, hydrochloric acid, plus, now sodium hydroxide, NaCl sodium chloride, plus, H2O water. The reaction between vinegar and baking soda is also an example of neutralization reaction. Neutralization reactions in everyday life. In digestion. You already know that our stomach secretes hydrochloric acid. This acid helps in the digestion of food. At times there is too much of acid in the stomach with indigestion and a burning feeling. It can be painful sometimes. In case of acidity, doctors prescribe antacids such as milk of magnesia, magnesium hydroxide, which are basic in nature. They neutralize the effect of excessive acid. Insect bite. When an ant or a bee stings, formic acid is injected into the body which causes itching. To get relief from irritation, baking soda paste, sodium hydrogen carbonate, or calamine lotion, zinc carbonate, is applied on the skin. Both are basic in nature and they neutralize the effect of formic acid. Soil treatment. Farmers use fertilizers to improve crop yield. Excessive use of fertilizers makes the soil acidic and plants are unable to grow well in such soil. When the soil is too acidic, quicklime, calcium oxide, or slaked lime, calcium hydroxide, is added to the soil to neutralize the acidic nature of soil. In case the soil is too basic, organic matter/manure is added to the soil. Organic matter releases organic acids which neutralize the basic nature of the soil. Factory waste. Acidic waste of factories is first neutralized by treating with bases before it is allowed to flow into the water bodies. If it is allowed to flow as such, the acids will kill fish and other aquatic plants and organisms. Brushing teeth. We brush our teeth with toothpaste as it is basic in nature. This helps to neutralize the effect of excessive acid. around the teeth and prevents tooth decay. Acid rain. Have you heard about acid rain? When the rain contains excessive acids, it is called acid rain. Carbon dioxide, sulfur dioxide, and nitrogen dioxide, which are released as pollutants, dissolve in the rainwater to form carbonic acid, sulfuric acid, and nitric acid respectively. Acid rain can damage buildings and statues made of marble, limestone, and plaster. The darkening and yellowing of the Taj Mahal is due to acid rain. Salts. When an acid reacts with a base, they neutralize each other's chemical properties, and salt and water are formed. For instance, when hydrochloric acid reacts with sodium hydroxide, caustic soda, sodium chloride, common salt, and water are produced. An acid and a base react to form salt. In this reaction, the base contributes the metal part of the salt while the acid contributes the non-metal part of the salt. The name of a salt is derived from the name of the metal, put first, and the non-metallic part later. Sulfates are obtained from sulfuric acid. Carbonates are obtained from carbonic acid. Chlorides are obtained from hydrochloric acid. Nitrates are obtained from nitric acid. Acetates are obtained from acetic acid. Properties of salts. Most salts are solids with high melting points and high boiling points. Most salts are soluble in water. Salt solutions in water are good conductors of electricity. Uses of some salts. Sodium chloride is used to flavor food, in pickles as preservatives, in curing meat and fish, in manufacture of washing soda, baking soda, and caustic soda. Sodium bicarbonate is used in baking breads, cakes, medicines, and fire extinguishers. Potassium nitrate is used in manufacture of gunpowder, fireworks, fertilizer, and in glass industry. Potash alum is used in purification of water. Copper sulfate is used in electroplating and as a fungicide. It is also used in cleaning, sanitation, laundry, and in textile industry. Silver nitrate is used in developing films in photography.